Hi everyone. Just a self-introduction. I'm Miss Felicia Yeah, so you can call me Miss I'm actually based at Overmugged, this outlet here, Bukit Timah. Yeah, so today we will be actually revising on as many chapters as we can for the physics end of year exam. Yep. This was actually the event that was held like 2 weeks ago. So we actually had one round. So this is a special second round just for IP students. Yeah, because back then it's just like in general. Yep. Just to share a little bit with you all about our team. We are actually a group of very young and dynamic tutors. Yep. So although we are young, but it doesn't mean that like we are not experienced. All teachers here are actually all university graduates. Yeah, and we have many years of teaching experience. Yep. So for Overmark here, we actually teach like O level IP, which is you all, as well as like A levels also. For Overmark, we actually have various branches. So right now where I'm at is actually the Bukit Timah outlet, but we'll be actually moving. Hello, take a seat, take a seat. Yeah, so we'll be actually moving over to Tan Kah Kee next year, so slightly nearer to Botanic Garden. Yep. Then we also have centers at like Parkway Center if you stay around East Coast area. Yeah. Then we also have like an outlet at Serangoon Central. Yep. Besides our regular centers, we also do teach at other spaces. Yeah, so we do teach at like Toa Payoh, Jurong East, and Woodlands. But mainly for Bukit Timah, it will be the main one for IP classes. Yeah, but of course, if there is demand in other areas, we can open IP classes also. So this is my name. So far I've been teaching mainly O level and IP. I teach from lower sec 1 all the way until upper sec 4. Yeah, so these are actually my students. So far for my track record is that my students have been doing well. Yep, so for O level students, like a lot of them get A1 and A2. Yep, then for IP students mostly do very well too. Like 80% of them get like A1 and 2 for end of year exam for sec 4. Yep. Then some background information about me. I actually graduate from NTU. I major in science, and that so far I've been teaching IP and O level, like I mentioned to you just now, upper sec and lower sec, and I teach like all three sciences. So before I joined Overmark this year, last year I was actually still at the learning lab. So I was previously teaching like for 7 years there. Yeah, then before I hop over Overmark. Yep. Then before the learning lab tuition center, I was in another tuition center. Yeah, I was in like Wisland, a smaller tuition center for like 2 years. Yeah, then I also did like quite a lot of relief teaching at various MOE schools. And then long time ago, yeah, I was like a private tutor. Yep. Usually for our lessons here is like for our lessons in sometimes I will also organize like experiments. Yep. Then here is a very welfare center. Yeah. So as you can see, like see you come for free lesson, we still give you like free goodie bags and all. Yeah. So you guys later I'll give you all soon. Yep. So it's over there because you all came in a bit late. I give you later. Yep. Then sometimes you order like bubble tea for them, like Koi. Then we order like pizza, KFC. Yeah. So it's like always having welfare. Then the students here usually like there will be like a free snack bar. So later if you find that you're hungry, you want more, you can go over outside there. There's like a row of like snacks that you can take like for free. Yep. So for the lesson today, we'll be mainly going through key concepts that is needed for your exams. If you notice later, I will give you my worksheet, where my worksheet will actually be mainly like just one or at max 2 page summary, mainly picking out the most important points, the key concepts, and I will also identify with you what are the common misconceptions that your friends might make. So then since you're here today, then you don't make that mistake. Yeah. And that for the difficult questions, I'll guide you through it on how to tackle it, how to approach it. Yep. And then the questions I picked are also the more commonly tested ones. So hopefully it's like something that might be similar to your exam. And then for some chapters there are answering techniques. So I'll be teaching you what are the essential keywords and like standard answer templates that you can use to write in your answer so that hopefully like you can get like full marks for that question. Yep. And then so we'll be besides notes, I will also be doing questions with you all. So there will be worksheet practice question for today. Yep. So let's make the most productive 1.5 hours today ever. Okay, for the lesson today, we'll be using this worksheet over here. So for those online, you can download this lesson material from either you follow the Overmark Telegram O level channel. So that means you just search on the Telegram, the search bar, just type Overmark O level. But I do not know why it's called O level when we actually post IP information inside lah. Yeah, so you can actually follow it. Then in future, when we have such freebie, like sometimes we will give out free notes or like free lessons. Yeah, so if you follow us, then you can get up to date on all these information. Yeah, if you can't find, then I will also be sending the lesson material link into the Zoom chat. Yep, so you can actually click onto the link over there to download it. Okay, so yep, I shall begin now. Let me distribute the worksheet to those who are physically present here. Give me a moment, ah. Okay, so let's start off with the first chapter first on measurements and the scaled vector diagram. So for the first page over here is just mainly need to take note that the letter M, it appear twice. So the letter M, if it's a quantity, it means mass. But then if it's a unit, it is meter instead. So don't get confused. Then another thing to take note will be letter T, because big T and small t represents totally different things. So small t is time, big T is temperature. The rest, I leave it to you to study on your own. I shall move on. So just to let you know that my lesson style is that whenever I write or highlight on the screen, you follow and note it down in your copy too. Okay? Okay, then moving on. Next, it will be on scaled vector diagram. So whenever you see a question that need you to draw this kind of scaled vector diagram, key point to check first is the object moving or not? So if the object is stationary, like at equilibrium, that means the resultant force is zero. So if the resultant force is zero, that means you cannot draw the resultant line. Resultant line meaning this kind, the double arrowhead line. So if the object is stationary, what I need to do is the lines should keep going in circles, something like that. Like you draw an arrow like that, then like that, then like that. So can you see that there is no start or end? The arrows will just keep going in circles. So this is for scenarios when the object is stationary, when there's no resultant force. As compared to an object that is moving, since the object is moving means like there is acceleration. That means if there is acceleration, then there will be force, right? Because F equals ma. Yeah, so in this case, if there is a force, that means, yep, you are able to draw the resultant line, the line with the double arrowhead. So usually for objects that are moving, it will be something like the bottom two like that, where you can draw a line with the double arrowhead for the resultant line. Yep, because there is a start and there is an end. So for moving objects, there are two ways to draw it. There's the triangle law and the parallelogram law. For me personally, I will usually recommend students to draw triangle law. The reason is because triangle law is there's less lines to draw. So when there's less lines to draw, you're actually making less mistakes. Because you see, if you only draw 3 lines, if each line you're off by maybe 0.1 cm, at max you only off by 0.3 cm. As compared to you draw this, there are like 5 lines. So wouldn't you draw more lines, then you will make more mistakes? Yeah, so usually it's recommended that you draw less lines. One is less mistake. Number two, you can save time during exam. And usually triangle law works for more than 2 forces. So 2 forces, you can use either way, triangle or parallelogram law. But if it's like 3 or 4 or more forces, the only way that it will work, it will be triangle law, which is another way of calling it is called the polygon method. Okay, so for triangle law, how does it work? You just imagine that at your starting position, you have this like, you play game, then there's like this cute monster over here. Then it's like the starting point. So for this monster, he will be like, oh no, I don't know where to walk. Should I walk up or should I walk down? So if the monster is like confused, don't know where to walk, and then he cannot split himself into half, okay? Yeah, so in this case, which way should he walk? So what you need to do is you have to shift or rearrange the lines. Yeah, so that like the monster can have a simple way to walk. Yeah, so one way would be maybe you can shift the bottom line, come up here, so that the monster walk up, then walk down. Or another way is you can shift this top line to the bottom, so that the monster walk down, then walk up. Yeah, so that means you need to shift the line such that the monster has a clear path to walk. But of course, when you draw it, you cannot draw like that lah. If you draw like that, then like where the monster start walking from? Cannot. So must be one clear path. As long as the monster can walk, then it's alright. Okay, so then in this case, for this question here, what they did was they shift the bottom line to the top. So can you see? It's going up, then go down. Then for resultant, you connect from the start to the end. Then you draw with a double arrowhead. Done. So this will be the answer. Okay, then next for parallelogram law, the method will be you duplicate the lines. Yeah, so in this case, the top line, you duplicate at the bottom with dotted line. Because this is not the real line. You duplicated it, right? The question doesn't have 2 upward arrow line. The question only have 1. So that's why if you duplicated it, it should be dotted line. Same for the other line. If you duplicate it, it should be dotted line. Then resultant, you connect from start to N. So that's why you start from the left side, you end. Arrows will all point to the right, right? So that you end at the right side. So the resultant you point towards the right. Okay, then after you are done drawing everything, then usually, like in order to get full marks, what is the teacher's marking rubrics? What are they looking out for so that you can get full marks? So these are the few things that you need to make sure that you have it. Number one, you need to have the scale. So for the scale, it is always recommended that is 1 cm it is to something Newton. Of course, if you want to like reverse it, even do it 1 Newton is to something cm also can. It's just that this is like the recommended way, but it's not compulsory. But then take note that when you fill in the blank over here, it has to be in multiples of 1, 2, and 5 only. That means you cannot give me like 1 cm is to 3 Newton. Cannot. Or 1 cm is to 7 Newton. Cannot. Yeah, so make sure that it's always in multiples of 1, 2, 5. So maybe it can be 1 cm is to 4 Newton, or 1 cm is to like 10 Newton. All these are okay. Because 4 is like 2 times 2. Then 10 also okay, cause 2 times 5. Okay, so then the second thing that you must have is, because this is a vector diagram, vector means that it has both magnitude and direction. So that means in your answer, I need to see the magnitude of the Newton, not cm, okay? So don't write in the cm. Don't write in as cm. The cm is just for you to know, like when you draw, like how many cm to draw. But when you write as the answer to show the teacher, you write in Newton, not in cm. Okay, if you write in cm, the teacher will just ignore it. Okay, then since we mentioned that there's both magnitude and direction, direction will be represented by arrowheads. Yep, so for those that is from the question, you cannot change the direction, okay? If your arrow point to top right, your answer in your drawing should still point to top right. You cannot change its direction. Okay, so if the question point to bottom right, you should still point to bottom right. You cannot suddenly change the direction. Okay, do not change the direction. And then on the fourth one, oops, a bit no space. Let me shift this up. Yeah. Okay, so the fourth one, it will be need to have the angle. So depending on the question, if the question told you that, oh, this is like maybe like 30 degree, and then you make sure that in your drawing, you need to show the 30 degree. So you must show the angle that is from the question. And if the question actually asks you, can you measure and identify the direction or the angle of your answer? So if the question asks you the angle for your answer, then you need to include also that. So maybe if for example, I said that the answer is like 180, then you need to draw 180, something like that. Yeah, so you need to like show the teacher where you get your answer from. Yeah, because if you say 20 degree, then the teacher might be confused, like, where do you measure the 20 degree from? Okay, then last thing to take note is that whenever it's angles, where you measure from, angles you always measure from the starting. That means you measure from the arrow tail. So that means like if I want to measure the angle of this line, I should measure like maybe over here. Like it's always measuring at the angle tail, not at the arrowhead. Okay, so it's always measured at the arrow tail, not arrowhead. Yeah, so that's where you do the measurement. Done. Yeah, so whenever you do your drawing, just make sure that you have these 4 points. Yeah, so this is actually the teacher's marking rubrics. That's how you can get full marks for this topic. Okay, so I shall move on. I take it that you all should be done copying by now, right? Okay, so moving on. Anyways, for those who just came online, the lesson material, I just sent it into the Zoom chat. You can download from there. Okay, so let's take a look at how can we apply. So the common kind of question that is like the more difficult kind, it will be these two. So this is the first version. The simple question is the kind that, they already give you two forces. You find the third one. That one is the very simple, straightforward question. But usually question, I don't think your school so nice to test you so easy, right? So usually they will test you with a little bit of difficulty. Yeah, so this is one type that is a little bit more complicated, which is that they only give you the magnitude of only one line. That means only one line, you have the amount of Newton. Then now they want you to find out what is the amount of Newton for the other two lines. So then usually if it's such a question, I give you one, you need to find the other two. Then how do you do it? So mainly is, since they give you one, you draw the one that you know first, right? Because that's the only information that you have. So you draw that first. Then the other two, usually they will give you the angle. You just make sure that you draw the angle accurately. then let the two unknown length to intersect them. So once they intersect, then you will know what's the actual length for it. So what do I mean by that? So for example, like this question here, they said that figure 1 below shows a photo frame of weight 50 Newton hung from a ceiling using two strings at an angle of 50 degree. Okay, so maybe I just include the values in first. Since they mentioned that the weight is 50, so I start from like maybe center, then you draw a weight down, then let's label this as 50 Newton. Yeah, so can you write this in? Okay, so with 50 Newton and then two lines at 50 degree, then they ask you to draw a scaled vector diagram. Yep, so in this case, because of time constraint, I won't be letting you to draw it out in class, but we just go through like the concept on how to draw. Then you go home slowly, use protractor and ruler to slowly measure. Okay? Okay, so first we have weight. Okay, so let's do a rough sketch or doodling at the side. So definitely for sure we have a downward weight. Yep, so can you draw a rough sketch will do? Don't need to measure lah. Just draw a vertical line downward do. So there's a downward weight. Okay, then next is these two lines, you do not know how long, but you know the angle, right? Okay, so maybe I draw for this line first. So what you can do is you draw a dotted line, then like by right, you should use a protractor to measure 50. Yeah, so after you measured like 50 degree, you draw a line that is long because you do not know how long this line is. They never give you the magnitude. Yeah, so you just draw a line that is long. Then next, you do likewise for the other line also. So this time around, since I'm measuring from vertical, so if I'm measuring from vertical, if I want to draw this line, I can draw it somewhere like here, right? Yep, so if I draw it somewhere here, can you see that if I add in the vertical line, this is like alternate angle, and this is like 50 degree. Yep, so that means in this case, over here, if I have a horizontal line, yep, I should draw a line that is 50 degree, like over here. You see? So right now what I'm drawing is this part here. Can see? Yeah, likewise. So then again, this line, you do not know how long it is. You just draw a line that is like very long. Then once the line intersect, then what you do is you take an eraser to go and erase the behind part. Yeah, so if you erase the behind part, then this will be your actual scaled vector diagram. Yeah, then yeah, so then after you done erasing it, then yeah, you're supposed to go and measure, right? Then write down the answer like, oh, based on how many cm is like how long. Then next is after you answer the question, you need to check. Do you have everything that is in the checklist that I mentioned just now, the 4 things? So let's check. Number 1, you need to have a scale. So that means in your drawing, you should have a scale of like 1 cm is to something Newton. So how do you decide how many Newton? You just make sure that it can occupy like at least half of the space provided. So your drawing cannot be too small. So that's 1, scale. Number 2, you must have the magnitude. So in this case, my lines don't have magnitude, right? So cannot. So magnitude of 50 Newton, let's write it in 50 N. So can you write it in? So number 2, magnitude. Then after you measure from the question, you also need to label how many Newton, okay? So that means after you have drawn accurately, make sure you label also the magnitude for all lines. Okay, then third is, because it's vector quantity, vector will have both magnitude and direction. So direction will be the arrowheads. So this time around, this arrow is pointing to the top left. Up to you. You want to draw at the tip also can. You want to draw in the middle also can. Both are acceptable. You just keep it consistent will do that for your drawing. So since just now I draw at the tip, so maybe I just continue to draw from the tip again. Yep, so add in all the arrowheads for all the lines. So that's the direction. Fourth, it will be the angles. So the angle showed 250 degree, right? So I should label 250 degree. Then I should label the angle from the question and from my answer. So in this question, did they ask you to find the angle? No, right? They only ask to find the magnitude. So there is no need to find the angle. So that means in my answer, I don't need to mention about angle. That means in my drawing, I also don't need to show any angle. Yep, so then done already. So that's the 4 key points that you need to have. So take note that after you done checking your answer, make sure you present your answer properly. Like in this case, they asking you what's the magnitude of the tension. So you should say that like tension equals how many Newton. don't go and expect teacher to go and hunt for your answer in your drawing. Okay, write a proper statement on the final answer so that the teacher can see clearly what your answer is. Okay, so don't expect teacher to go and find it from the diagram. Then done. Okay, so this drawing, I shall leave it to you to go home and slowly draw it out accurately. So I shall move on. So just to check for those online, are you all done like noting down all the hints over here? If done, can you click the thumbs up reaction button to let me know? Then I'll move on. Maybe for XH, do you want to maybe take a screenshot then so that I can move on? So I move on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so to the next question, it will be this kind. When object is at equilibrium. So just now I mentioned to you that whenever objects are at equilibrium, is that you cannot draw the resultant line. You need to make sure that the lines keep going in circles. So that means in this case, you need to rearrange them such that they keep going in circle. So now, if I were to start from the center, so if I have a monster that is over here, my monster will be like confused, right? Don't know where to walk. Like, should we walk left, right, or down? So that the monster will be headache. Oh no, don't know where to walk. So what you need to do is you rearrange the line such that the monster knows how to walk. Yep, so maybe I start off from the weight again first. You can start with any line. There's no fixed rule. So maybe I start off with the weight first, which is vertically down. Okay, then next is if I move down, then since I got space on the right, maybe I go to the right first. Yep, so then what I will do is from the vertical line, I need to measure 37 degree. So that means from the vertical line, I measure 37. Okay, so then for the 37, by right, you should draw to scale because they did mention to you that this line will be 360 Newton. Yeah, so that means you draw at an angle of 37 degree, but now you don't draw to scale, okay? You just draw a sketch will do. Yep, so just sketch at the side. So you measure 37 degree later. Yep, then you draw a line that fits 360 Newton based on your scale. Then next is over here, there's another line. So for this line is from the horizontal. So I'll draw in the dotted line. Because later they mentioned that you are supposed to find the magnitude fx and the angle. Yep, so that's why in this case, to find the angle, I'll draw the dotted line. But then this time round, I do not know what angle it is. So how to draw? So the thing is that you know clearly these two lines is confirmed correct, right? Because it's you got the length, you got the angle. So what you do is you just connect here to here. Because once you connect here to here, it will be accurate already because the other two lines are accurate. Then once you connect, then later you can measure what's this angle. Then this angle will be your theta. Then later you measure the length. The length will tell you fx. So same thing, you should also label like how many Newton after you did your measurement. Okay, so likewise, so in this case, let's check like whether we have the 4 checklists that we mentioned. So number 1, need to have the scale, right? So that means at the top, you should write down the scale. Recommended is always 1 cm is to something Newton, and the Newton must be in multiples of 1, 2, or 5 only. Then the second one is that it will be vector. Vector means that it will have both magnitude and direction. So let's check. Do I have all the magnitude? For the weight is missing. So weight is 450 Newton. Yep, so you label the magnitude, magnitude, magnitude. Okay, so magnitude settled. Next, magnitude and direction, right? The arrowheads. Are all the arrowheads in? Nope. So let's add it in. This is pointing to top right. This one is pointing to top left. So take note, okay, if the arrow point to top left, it must point to top left. You cannot change its direction to become like bottom left. Okay, then done with magnitude and direction. Lastly, it will be the angles. Yep, so for the angles, they only showed 37 and theta. And I have both 37 and theta, so yep, it's all in. Then for my answer, which is theta, yep, I also did label it. So yep, so my drawing now, everything is complete. Yep, then finally, answer back the question. So the teacher asks you to find fx, then make sure you have a proper statement to say that fx is how many Newton, beta is how many degree. Okay, so must have a proper statement to show teacher your answer. Then done, that's for scaled vector diagram. Okay, so I shall move on. Should be done by now, right? I move on in 3 seconds. If you're not done, you take a screenshot. 3, 2, 1. Okay, moving on. Next part over here, it will be on kinematics. So for kinematics, need to know the various equation of motion. I think you all should know what each of the alphabet represent, right? So I think later we just directly try our question to see whether you know how to use the formula. Anyone need me to recap like what each of the letter means? You know what all of them means, right? Can I move on? Okay, then next is for graph. So for graph, need to know that how to convert from one graph to another graph. Yep. So there is actually a trick to it. Yep. So how you interpret it? Okay. So maybe I go through this first. Okay. So you need to know that when you look at the displacement time graph, the gradient of the displacement time graph tells you the velocity. So that means when you measure the gradient like y2 minus y1 over x2 minus x1, that value is the velocity. Then likewise, in a velocity time graph, when you look at its gradient, it will tell you the acceleration. But acceleration time graph, don't go and look at the gradient anymore, okay? There's no more arrow for the gradient already. That's why I mentioned that in acceleration time graph, there is no need to read the gradient. So for acceleration time graph, the only thing you can read is the value itself to know how much acceleration it is or the area under graph. But the area under graph, to be more specific, is the area between the graph and like your x-axis lah. So that means if your graph is like underneath, yeah, so if your graph is like here, then the area under graph, it will be like this. Not under, it will be between the graph and the x-axis. Yeah, this one not very crucial. Okay, let me just erase it. Okay, then next is for the velocity time graph. If you look at the area under it, like you go and count like the area of triangle, trapezium, rectangle, square, it will tell you the displacement. Okay, then next is for a displacement time graph, what are the things that you should look out for? So this is the tips. Yeah, so once you follow this guideline, right, usually you'll be able to interpret all the graphs accurately. Okay, so let me show it to you. So for example, if I were to say that, wait, I mean no space. Okay, maybe I draw here. Wait, I mean no space. Okay, I draw on top. Okay, so if I were to say that maybe my starting point is like maybe over here, then the race should end on the right side. So if I start from here and end at here, so if I were to have a displacement time graph that is of a positive gradient and then it's above the x-axis, so this will mean something like that. By the way, displacement is letter S. S is not speed. Speed is V. Remember like the KE formula? KE is like half mv squared, V is the speed. So S is displacement. Okay, so in this case, if I were to have a graph that is positive gradient like that, you all know math, right? Upward is positive, horizontal is 0, downward is negative, correct? So if your graph is positive and then it's above the x-axis, this means that it is moving forward and at the positive side. So meaning if I have this graph, my object should be like that. Because I start from a displacement 0 and I will end up at the positive side because I'm above the x-axis. So can you see that on the right side will be positive because you base on the start line, right side will be positive displacement. Before the start line, it will be negative displacement. So in this case, yep, so the particle will be moving this way because it's positive gradient, it's moving forward, and then it's above the x-axis. So it's on the right side. Okay, now let me draw another example for you. What if I have negative gradient and then above the x-axis? That means my graph will look something like that. Come down. Yeah, so that means I have a negative gradient cause downward sloping, but then it's above the x-axis. So in this case, where will my particle be? So since I'm above the x-axis, I'm at the positive side. So I should be on the right side. But I'm reversing. So that means instead of going towards the end point, I don't go towards the end point. I reverse. That means I'm moving this way. Yep, so this will be the motion of the particle for this orange graph. Yeah, so if you can, I'll recommend that you also like follow and draw it out, yeah, so that you can better visualize it. Okay, then next it would be another scenario where I have positive gradient, but then my graph is below the x-axis. So in this case, it will look something like that. Then this is, I'm drawing positive gradient. Okay, so it's going up. Okay, so if my graph were to look like this, then how will my particle be moving? So I'm moving in the forward direction, but I'm at the negative side. That means negative is on the left side. So I'm on the left side, but I'm moving forward to the endpoint. That means something like that. So this will be how this is. Okay, positive gradient, but below the x-axis. Okay, then the last one will be negative gradient and below the x-axis. So that means it would be this way. So in this case, since I'm at the negative side and I'm moving in reverse, that means it will be like this. Okay, I start from 0, right? Yeah. So start from a displacement 0, I move this way. Yeah, so this will how it look like. So this is how you can interpret them. So using the legend. So once you follow the legend, you can know how the particles are moving. Then of course, the lines will not always be straight. Yeah, so if the line is like curved, yeah, then you just check the gradient. Is the gradient increasing or decreasing? So the gradient will then tell you how is the speed changing. Is the speed increasing, decreasing, or constant? So in this case, what I've drawn are all constant velocity. Okay, so done for displacement time graph. Next, I'll move on to velocity time graph. So for velocity time graph, take note, the gradient will be different thing now. Why? Because the gradient of the displacement time graph just now was telling you the velocity. So it's like telling you, okay, positive velocity means I move forward. Negative velocity means I'm moving backward, I'm reversing. So now the gradient is no longer tell you the velocity anymore. The velocity time graph gradient tells you the acceleration. So if it's a positive gradient means positive acceleration. Then if it's a negative gradient means negative acceleration. That's why actually for deceleration, we can actually further divide it into two types. So for deceleration, you can either mention that it is an acceleration in the negative direction. That means I keep accelerating further and further away from my endpoint. So that's one method. Another method is that it can be I am not speeding up, but I'm slowing down. So it can be that I'm slowing down in the positive direction. Yeah, so there's two ways to interpret it. Okay, maybe let me write clearer. It's not clear for the first one. Okay, so for the first one, it can be speeding up in the negative direction. Yep, so you just either one negative will do. Either your velocity is like negative or your direction is negative. So for the first case is I make the direction to be negative. Then the second case is I make my speed to become like negative, like I'm slowing down. Yep, so deceleration can be interpreted two ways. Then next is you can check also, is it above the x-axis or below the x-axis? Because if above the x-axis, that means my velocity will be positive. So positive means it's moving forward. But if it's below the x-axis, like this kind, like maybe the line is here, then it's a negative value, right? So if it's a negative, means I'm reversing. Yeah, so that's how you can interpret. Then lastly is for acceleration time graph, just check. If the graph is above the x-axis, like this AT graph, if my line is above the x-axis, means my values here are all positive, right? So that means it's positive acceleration. But if I draw a graph that is here, like maybe like negative value, and then this is called negative acceleration. And as mentioned, right, that negative deceleration is actually negative acceleration because it can be like I'm accelerating, but in the negative direction. Okay, so take note that deceleration can also means negative acceleration. Yeah, so can you write this in? Oh, I realized the printer went to rotate it because this one's supposed to be landscape. Yeah, then because your page very small, oops. If you all need a bigger page later, maybe after class I can print it bigger for you. Okay, so done for this part. Then lastly is after the graph drawing, sometimes they will ask you to write sentence, right? So take note that whenever you write sentence, don't use the word rate of change of. Rate of change of is where you learn it from math. Actually, physics, they don't recommend, they don't teach you in school actually, back then when you were learning this topic. They don't tell you to write rate of change of actually. Why? Because when you say rate of change of, you are looking at the gradient. Then when you look at the gradient can mean different thing. Because if you are looking at the gradient of displacement time graph, the gradient is the velocity. But if you look at the gradient of a VT graph, it can tell you the acceleration. So when you say rate of change on it, it's like, are you talking about velocity or are you talking about acceleration? So it's like very confusing. So you just directly go straight like, oh, if you want to say that the rate of change of the graph is like increasing, then just directly tell me, oh, like velocity increasing or acceleration increasing. You just directly tell me the actual word that's needed. Don't like ambiguous, like rate of change of. Okay, then next is things to take note will be that when object is undergoing free fall, whether there is air resistance or not, the graph for heavy and light object differs. If don't have air resistance, right, a lot of students tend to be misconception. They thought that heavier object will fall faster, but that's not true. The heavier object fall faster is when there is air resistance. Without air resistance, heavy and light is the same graph. So that means if I draw this graph for heavy object, this graph is also for light object. It's exactly the same. So a lot of students tend to like get this misconception that they thought that is different. Yeah, but take note, okay? With versus without air resistance, it matters. Why? Okay, so let me just show you this quick video. I'll just show you a short clips will do. Yeah, because I don't have that much of a time. Maybe your school teacher might have shown you before. So I'll just voice over it. It's actually this video about the world's largest vacuum chamber. Okay, so right, what happened in this video, right, is that what they did is they raised bowling ball and feather at a super high position. So right now this guy he's still inside. That's why there's air still. Yeah, so you realize that because he's around, that means it's not vacuum yet. You realize that heavy object falls down faster, but light object fall down slower. This is with air resistance. So next is they are going to like seal up the place and then with like machines to suck out the air such that inside it becomes like a vacuum. So when inside becomes a vacuum and then they actually release the ball and the bowling ball and the feather. Oh, this is played in slow-mo, okay? Yeah, I just wanted to show you that when you release the in the vacuum, do you realize that both different mass object they are falling down at the same speed? So take note that in the absence of air resistance, that means vacuum, object of different mass should come down at the same time. Proven to you, okay, from experiment. So why is this so? Okay, so let me show it to you. The reason is because when you count speed, the formula for speed is distance over time, right? Do you see the letter m, like mass, inside the formula for calculating speed? Don't have what? That's why mass don't affect. So the one that you might think that, oh, is it because like mass then like affect speed? Is it because of the KE formula? Because KE is half mv square ma. Then you think of like, oh, mass, then like, heavier, then like more KE. True. When an object have more mass, they have more kinetic energy. But right now, I'm not asking you how much kinetic energy it is. I'm asking you the speed. So it's different question. So if I ask you the kinetic energy, yes, bowling ball have greater kinetic energy. But now I'm asking you the speed of them falling down. Speed don't have mass. That's why the mass shouldn't affect the speed of it falling down. That's why the graph is the same for both heavy and light object. As compared to when there is air, this will be the typical one that is in the textbook, right? The one that they say what? The skydiver jump, then after a while, like he reach what terminal velocity, open parachute thing. Yeah. So in that case, weight do matter. Why? Because how can you achieve the horizontal line? The horizontal line is your terminal velocity, right? So for terminal velocity to reach is where the upward and downward force must equal to each other. That means the weight and air resistance must be equal to each other. So in this case, if your weight is like if you are a very heavy person, if your weight is a lot, that means you need to have a lot of air resistance, right? To have a lot of air resistance, how? The only way is you have higher speed because air resistance depends on speed and surface area. So in order to balance out the huge weight, for me to have a huge air resistance, I need to have a huge speed. That's why for heavy object, they will have a huge speed. Okay? Yep, like that. Yep, so what I mentioned to you is over here. That greater mass means greater weight. Means you need more time for the air resistance to keep increase until it can be big enough to be equal to the weight. Then that's when you reach terminal velocity. Yes. Density? Yeah. Density means like mass over volume. So mass, yeah, it will also affect. Yeah, it will affect also. But usually when we look at air resistance, usually we directly use the word speed and surface area, not density. Yeah. That's the proper way to term it. Okay, then next is terminal velocity, which is this horizontal part. This one is like an answering technique. Yeah, so this one need to know. Can you label as answering technique? So whenever question asks you like what happened, like after the person fall for a long time, then you know the answer is terminal velocity, right? So how do you explain terminal velocity? These are the keywords needed. You need to mention the direction, because when you talk about force are vector quantity. So must indicate the direction for the vector quantity. Then when the upward air resistance and downward weight are equal to each other, that means resultant force is zero. If F equals ma, F is zero, A will be zero. If you are not accelerating, means you are traveling at constant speed. So that's why terminal velocity is when the speed is constant. Then done. That's all for the recap. Okay, so let's try out this question here. Actually, just to let you know that the top question and the bottom question is similar. Yeah, but it can be seen that like the schools like to test this kind of question and it's a little bit challenging. I let you try out first, see whether you can squeeze out some brain juice to figure out the answer. Yep, so can you all try question number 1 now? You try first lah. If you really cannot, no worries. I'll go through after your try out. Yeah, so you give it a try first. See whether can you do question number 1. Yeah, so do question number 1 now. If you are lost, my hint would be you draw out the diagram. You draw the ball go up, go down, you label all the timing. If you are totally clueless, you can try that. You draw out the movement, then you label all the timing. Yes. So how can not? You see, it appeared in like 2 schools exam already, recent years. For those online, if you manage to solve it, which is a good sign, if you can solve it, maybe you want to let me know what is your answer, like A, B, C, or D. Then I can let you know whether you're correct or not. And those physically present also, if you manage to solve for an answer, you can let me know. Then I can tell you whether is your answer correct or not. Have you solved it?
I don't think I'm correct.
No, your hunch is right. No. No, the last answer is out. The answer is C. Okay, good try everyone. Okay, so okay, come, let me go through it with you all. Okay, so for the question they said that maybe okay, we assume that this is the level where there's the window, okay? So when you first go up, it's 1.2 second. The next time when he passed by the window, it will be 2 seconds. So over here is like 2.0 second. So the thing is that actually the time that you go up and the time that you come down is it will take the same amount of time. So the thing is that from a 1.2 second to 2 second, how long is this duration? This is a 0.8 seconds difference, right? Since I say you go up and you go down, it's the same duration. The whole thing is 0.8. So one way will be how long? One way will be 0.4 seconds. That means you go up, it will be 1.6 seconds. Then another 0.4 to come down. Okay, because the time that you go up and come down, it should be the same. Okay, so you'll draw this in first. Okay, then next is that now you have to calculate the time taken from the ground. You do from the ground to the highest point. So from the ground to the highest point is 1.6 seconds, right? So then now you can use the usual formula, the A equals to V minus U over T. So based on from the ground to the highest point, do you know how to sub in the values now? You give it a try. So usually the first direction you move, it will be the positive direction. That means if you first move up, that means taking upwards as positive. Make it a habit to always write down the direction. Because we are doing like vector quantities like acceleration, velocity. Yeah, so sometimes might have a negative sign if you're going in opposite direction. Yeah, so you'll give it a try and sub in the numbers. Then see whether can you get the answer of 16. Okay, so let me demo to you the working. Yep, so you'll be what, like this. So that's why the answer is 16. Okay, so the answer will be C. Okay, so question number 2, it will be very similar. It's almost the same. It's also like the thing go up then come down. I let you try on your own at home. The concept is the same lah. You just make use of the concept that you learn here. You draw likewise for the diagram below. Or actually, they also did draw it for you already lah. Yep, so you can figure it out on your own bah. So I shall move on to the next page. Okay, so question number 3 over here. So they said that the figure shows the vertical velocity of a ball falling through the air varies with time. Then you see, whenever there is air, you should draw it such that you will reach terminal velocity. Okay, so for the front part, they are all very simple question, like one step can get answer kind. I leave it to you to complete it on your own. I want to go through the slightly more difficult part, which is part D. Okay, so let's take a look. The ball hits the soft ground and decelerates uniformly at 150. So that means, in other words, when you see the word decelerate at 150, this means that the A value is negative 150. Yeah, write it in. A is negative 150. So now they are asking you for the time taken for the ball to come to a complete stop. Okay, so now given A, T, and in the graph, they show you V. Which formula do you think you can use with A, T, and V? Which formula can we use? This is simple. Which formula can we use? Correct. A equals to V minus U over T. Can? So I let you sub it in on your own. I already showed you the answer. Like A is negative 150. Yep. Then the V and U can find out on your own. Okay, then moving on to part 2. Determine the distance traveled by the ball into the soft ground. So distance, it will be letter S, right? So in this case, which formula do you think we can use for this question? So you got S, got T, got A, just now got V in the graph. So which formula do you think we can use? V squared equals to U squared plus AT. But then in that case, like that, your formula don't have S left. Right. Use V squared equals to 2 squared, U squared plus. V squared equals to U squared plus. Oh, you mean the V squared equals to U squared plus 2AS, is it? Can also. That's one formula. Then there's also another formula. Okay, let's just write down. So you can either use the V squared equals to U squared plus 2AS, or you want to use another one also can. More straightforward lah. Since they want distance, make S the subject law. So as the subject, you use this, I think more straightforward. Yep, so both formula works. Yeah, usually for kinematics, there's more than one way to solve it. Okay, so I leave it to you to solve it on your own. You just sub in the numbers on your own at home there. So I shall move on. Okay, so I shall move on in 3 seconds. For those online, if you're not done, maybe you want to take a screenshot. Moving on in 3, 2, 1. Okay, moving on. Okay, so then the next chapter is on dynamics. So for dynamics over here, mainly is linked to the Newton's three law. How do you differentiate the three law? I think the third law very obvious. Because third law is about the action-reaction force. So I think no problem. It's about when do you use first law and when do you use second law. It's mainly you check got resultant force or not. Because if there is no resultant force, it is Newton's first law. If got resultant force, it will be Newton's second law. So for Newton's first law is saying that, remember? The object at rest will remain at rest. The object that is in motion will continue in motion at a constant speed in a straight line. So all this is assuming when there is no resultant force. Something like maybe you are in outer space, not near any planet, don't have any gravitational force. So if you are out there without any force, the object that is stationary will remain stationary all the way long. Then if it's moving, yeah, it will just continue move in a straight line at a constant speed forever. Then for the second law is about the formula, right? The F equals ma. Yeah, so that's why did they give you formula? It's because got force, then you can calculate ma. That's why they give you the formula is when there is force, they need to do the calculation. So usually second law is when the object accelerates or decelerates. Okay, so then the third law, it will be action-reaction force. So take note that for action-reaction force to be true, like if they are really truly action-reaction force, you must make sure that you fulfill all four criteria. Must fulfill all four. If you fulfill like 3 out of 4, then cannot. Must fulfill all four. So one is the amount of force must be equal, like maybe 5 Newton and 5 Newton. Then it must be on different body, like A acts on B, B acts on A. And then it must be directly opposite direction, like 1 point left, 1 point right. And then they must be the same type of force, like maybe both are like, the common type of forces I would say is like normal contact force. Yeah, because when things are touching each other, yeah, they will contact with each other. So both sides has normal contact force. Another one that you want to write like maybe like weight, but usually for action-reaction force, we tend not to write as weight. We write it as gravitational force. Because if you go to JC, the gravitational force definition, right, is actually the attraction between two masses. That means as long as two objects got mass, they will attract each other. Yeah, so that means in other words, like when I jump, right, you can see the earth attract me down, right? That's why I come down after I jump. But then for me, when I jump, actually I'm also attracting the earth up. Just that because I'm very tiny, I'm very like small and light. That's why me pulling the earth up is like negligible. You can't really see it. But actually there's an attraction. Yeah, so that's why better to write gravitational force, not weight. Because weight is only one way. Pulling the object to the center of the earth. But don't have the reverse. Okay, so I shall move on. Done, right? Okay, so then next part over here, this one I think very seldom tested. Like, it's just like the direction of the friction to label. So take note that when it's free moving wheel, that means like maybe like a wooden toy car kind, like don't have any engine and at all. So if it's a free moving wheel, you can tell that the car is facing this way, right? That means the car is moving this way. So if the car is moving this way, the friction is pointing to the right. Why? Because you just imagine, if my surface is like oil or like ice, if it's so smooth that don't have friction, do you think the wheel will rotate or not? If the surface is so smooth, will the wheel rotate? The wheel won't rotate, right? The wheel will just lock in place and just glide if you were to like push it. Yeah, so the wheel won't rotate if the surface is too smooth. So only when the surface like got some friction, friction causes the wheel to turn. And then in this case, since the car need to go forward, that means the wheel should turn this way, right? So that the car then can drive forward. So that means this time around, since the only force that is present is friction, that means friction is the only force that can turn the wheel. That's why the direction of the wheel is this way, and friction is the one that caused the wheel to turn this way. That's why friction is pointing to the right. Okay, then now, if we compare it to engine-powered wheel, that means like maybe, like the cars out there on the road, those that got like petrol, the real vehicle, or maybe like bicycle, you pedal to force the wheel behind to turn. Do you realize, you see, for free moving, this is the free moving, free moving versus the engine powered. So this one, it's not engine, this is more like my leg power. Okay, so instead of engine powered, it's leg powered wheel. Yeah, is that, do you realize the direction of friction is opposite? Because for the behind one is that when I pedal, I will definitely pedal it this way, right? Because when I pedal, I force the wheel to go forward. I need to turn this way. So this is the direction of my engine force. Then you know friction always like to oppose motion, right? So since my engine force is pointing towards the right near the surface, that means my friction should point to the left, so that friction can oppose motion. Yep, so that's why in this case, friction point to the left, not to the right. Yeah. So the analogy is that because the understanding is because for the behind wheel over here, what are the forces? The forces is you have the engine force and you have the frictional force. So if there is some other force, of course the frictional force will try to oppose it. That's why the frictional force is trying to oppose the rightward engine force. That's why friction point to the left. But for the front wheel, what are the force present? There's no engine power. So that means the front wheel only experience friction. So in order for the bicycle to move forward, you can tell, right? The bicycle is moving to the left. In order for the bicycle to move forward, friction has to rotate the wheel. Because without friction, the wheel won't even rotate. It will just stay in place and then just glide. Yeah, but with friction, the wheel can rotate. That's why this time around, the friction would rotate the wheel such that the bicycle can move forward. That's why the friction direction is opposite. Okay, so but usually this topic, they don't really test you on labeling. Like they usually test you on calculation instead. Okay, so let's take a look at the calculation. I move on. Those who are not done, maybe you want to take a screenshot. I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so over here, one of the commonly tested question would be like, I have a string. So then you need to know how do they move. Yep, so what you need to do is you have to do like box by box. Yep, so what you should do is maybe you do for this box first. So for this box, it will get pulled forward, right? Because of the string. So that means for the, oh no, I think I labeled wrongly. Oops, maybe can you help me to change it? This one is for the right side box. This one is for the left side box. Sorry for the wrong label. You all amend it? Okay, so now let's take a look at the left side box. So since the only force is tension, so you let it to be equal to tension, and there is a method that I usually teach my class students is that you just follow this L-shaped method, right? Usually all kinds of dynamics, difficult solving question, you can solve it. The method will be this L shape. So what is this L shape? This L shape is where whenever you write, right, you always base on, you write down FR, right side, you base on the free body diagram. So that means like in this case, the free body diagram show that you have a force pointing to the right, tension. So over here, I'll write tension. Then below FR, I will always write the formula. Yeah, MA. So usually, as long as you follow this L shape, then later you sub in the values, you should be able to get the correct answer. So let me demo to you how to use it. So in this case, it will be you sub in T for the right side, then below MA. Then that's all, no other information we have. Cause the question, everything is like unknown. Okay, so done for the left side box. We move on to the right side box. So for the right side box, what are the forces present? So you can see that the force is being dragged forward by the force F. But this box can't move forward that freely because of the string. The string actually is tied to another burden. Yeah, so since the object not able to like move freely due to the string, yeah, that's why in this case, the force will be forward force F minus the opposing force, which is tension. Yeah, so it's F minus T. So you see, I am using the L shape again. So the L shape would be the forward force minus the opposing force for the free body diagram on the right side. Then below, you write now MA. Then now, since they're asking you to solve for T, so then now you try to solve for T. And since happen that both box, the mass are the same, so the M are the same, and that's as long as they are tied by the same string, definitely they will have the same acceleration. Even if the question never say, you should know it, because same string means they move at the same speed, same acceleration. Yep, so that's why in this case, yep, the M and A happen to be the same. That's why you can let F minus T equals to T, then you solve for T. Then done. Then the answer will be B. Okay, so this kind of method that you can use will be for questions like question number 2. Can you see? Also like string, hold on to it. Yeah, then you do likewise also. You do box by box. So that means like for this one, you do for this box first. Then later, you do for this box. Yeah, just do separately. Yep, then later you just solve for the acceleration. Okay, so take note on this method. You can write down at the side here to remind yourself that use the L-shaped method. You give it a try on your own at home, then I think you should be able to solve it. The one that I want to go through is the question number 1. So this one I need to explain to you all verbally. You all give it a try first. You all try question number 1 now. Oh yeah, by the way, for those of you asking like about the third session on the bio revision that is happening today at 7:30, I think. Yeah, 7:30, yeah, correct. The topics will be on molecular genetics, inheritance, infectious diseases in humans. Oh, sure. Molecular genetics, inheritance, infectious diseases in humans. Oh, you don't have any of it? Oh, okay. Then maybe you can head home then. Or maybe you just take the notes or the bio notes. Do you take the bio notes from the shelf there? Oh, okay. Maybe you can take the notes there. I think maybe like different school teach slightly different topics. The topics that these topics are definitely relevant for the Nanyang students because we got from the Nanyang students. Yeah. Oh yeah, just to let those online know is that because y'all are online, for those who are attending physically, we actually are giving them this revision booklet. Yep. So we actually have for Sec 3 IP Physics. We also have for IP Chemistry. Yep. So if you want to receive a copy of this, you can actually head down to the Bukit Timah outlet of Overmug. Yeah, so we are located at like directly opposite of King Albert Park MRT. Yeah, so you can come and collect if you want. So we also have like other subjects like A Math, E Math also have. Yeah. And then we also have pure biology also have. Don't have IP bio, but got pure bio. Yeah. So for those online, do you all have answer ready for question number 1? It is normal that you can't answer the questions because I purposely going through the difficult one, right? Because easier one you'll do at home. The difficult one I go through now. So it's normal that like the question that I ask y'all don't know how to answer. Because I'm planning to go through it actually. So how any of you have any answer? Sam correct. Kaylin not correct. Good try. Any of you got any answer? Hmm? No answer. Okay, then since no answer, then I think I go through. The answer is C. The answer is C. Okay, so how to get this answer? So mainly if I ask you, you just imagine maybe I don't know whether have you done it before. Skydiving. You know when skydiving, usually it's tandem, right? Because we ourselves we don't know how to do skydiving. We need an instructor, right? Instructor. So usually, skydiving usually like they jump together with the instructor on top, then like the participant is like at the bottom. So usually when you are skydiving, do you think the two body will be sticking so tightly that like the heavy person on top like pressing down on you? I don't think you really feel the weight of the person on top of you, right? Because sometimes there might be even a gap between them also. Yeah, so that's why usually when you're free falling, you won't be able to feel the weight of the person on top of you. Why? Remember the video that I just showed you, the bowling ball and the feather? Different mass object, when they first fall, they will be able to fall down at the same speed. Yeah, and some more this time around, they mentioned the word vacuum. Can you see the word vacuum? Isn't it exactly the video that I showed you? So if both objects falling down at the same speed, that means the on top is not pressing down hard. That means the 2 kg is not pressing down hard on the 3 kg, right? Because they move at the same speed. So that means it will be they're just falling down. So that's why in this case, the 3 kg box cannot feel the presence of the 2 kg box because they fall at the same speed. Unless the on top fall faster, on top fall faster, then yeah, you will squash the below person, but they are falling at the same speed. So that's why they are also falling at the same gravitational acceleration also. That's why in this case, the answer should be the force that is on the 3 kg box will just be its weight lor. That's the only force. Okay, so the answer will be W equals to mg, so it's 3 times 10, 30. Or if your school use 9.8 or 9.81, you round off, choose the nearest answer, then the nearest answer is 30. Okay, done. Okay, so then I shall move on. The other two are slightly easier. This one, I already taught you the concept, use the L shape, so should be no problem. This one, you give it a try, this is easier. Okay, so for question number 4 here, I'll go through A and C part 2. Okay, so the question says that a helicopter takes off vertically into the air. It starts from rest at t equals to 0 and has an upward acceleration of 0.5 meter per second square. The mass of the helicopter is 13,500 kg. You take G to be 10. So part A, when the propeller rotates, the air below the propeller pushes the helicopter upwards, generating a lift force. The lift created by the helicopter's propeller and the weight of the helicopter are not a Newton's third law of action-reaction pair. So now they want you to identify what is the other force that's action-reaction pair with the lift. Okay, so let's highlight the keyword. They want you to identify which is the force that is action-reaction pair with the lift. So that's the first part. Then the second part, it would be that you need to state which body is it acting on. Okay, so then, so for the first part over here, since it's action-reaction force, so remember the 4 criteria of action-reaction force. So for action-reaction force, they must be first the same type of force. So that means in this case, what's the name of the force that I should give them? If I want it to be like same type of force. So what's the name of the force here? What's the name of the force? There, over here. What's the name of the force? Lift. Ah, correct. So that means if you want it to be the same type of force, means you must use back the same spelling, right? So that means it should be the lift also. So that means the action-reaction pair will be the lift. The lifting force, the lift. And then in this case, done. For first part, it must be the same type of force. Second part, what's the second thing? Second thing is that it must be acting on opposite bodies and opposite in direction. So what's the direction originally? The original direction it is, they mentioned over here, the lift is created by the propeller. And then, oh yeah, over here also, then they mentioned here, the lift force, oh I highlight this. The lift force is, when the propeller moves, is by the propeller on the air below it. So if the lift force is by propeller on air, so if it's an action-reaction action-reaction force, it should be by who on who? Must be opposite direction and opposite bodies. So how should I phrase it? By air on helicopter. Yes, correct. By air pushing on the helicopter. Yep, correct. Good. Okay, so done for the first part. So in this case, because they're not only asking you to state, they ask you to describe. So that means we need to further elaborate. So this is just stating only. We need to describe. Okay, so how do we describe? So just describe like what is this about? Yeah, so mainly is to create a lift, right? So to create the lift, yeah, the helicopter will actually, like when they turn, the rotor, they will actually push the air down. So when they push the air down, then in the end they can push themselves up. Yeah, so that's why I must mention that the helicopter's rotor push the air downwards. Yep, that's why in the end creating the lift. Then lastly is need to state the body on which it acts on. So that's why the force from the helicopter acts on what thing? So what is the body that it is acting on? It's very obvious. What's the answer? Yeah, correct. Thank you very much for keep answering me. Because I don't like to monologue. I don't like to I ask you a question and then I answer myself. A bit lame. So yeah, usually I prefer responses. Then I also know whether you understand or not. Okay, so moving on to part B, determine the resultant force. This one should be easy. Resultant force is just the F equals MA, right? I think should be no problem. Then the next part asking about weight. Weight, I think you all should know. W equals to mg is easy. So moving on to part 2, I will go through. Hence, calculate the upward lift force exerted on the helicopter by the engine. So remember, whenever it's calculation question, what do you need to think of? How to solve? Whenever it's calculation question, I taught you the tip, right? Ah, the L shape, very good. The L shape, yes. The cute, you all point this way. Yep, so it's the L shape. Okay, come, let's write it down. So for the resultant force, since the whole helicopter is moving up, so what should I be writing? It means upward force should be greater, right? Since the whole helicopter moving up. So what's the upward force? What is it called? Correct, it's called the lift force. So besides the lift, what other force does the helicopter experience? Correct, the weight. Yep, so lift minus weight. Then below FR, you need to write in what thing in the L shape? M, A, correct. Yep, then you just sub it in law. So in the top, we actually did like the part B and part C, part 1. You just sub in the numbers from there lah. Okay, so this one I leave it to you to finish up on your own. Okay, then part D, they said that a skydiver jumps out from the helicopter and begins to fall. After a while, he begins to fall at terminal velocity. Explain in terms of forces what happened during terminal velocity. So how do you all know what's the answer? Oh, very good. I see some of you all flipping the notes. Do you all know which page of the notes you can find the answer from? I mean like today's worksheet, yes. Today's worksheet, which page? Page? 4, is it? Let me just double check to make sure that you're on the correct page. You'll say 4, is it? Over here. Yes, correct. The one on the right side here. Can just copy the entire thing. Then you see all the weight, all the forces are included already. Like air resistance, weight, and all. Okay? Yep, so the answer is page 4. Yep, so can you write it in? That you can find it from page 4. Then I leave it to you to copy on your own at home. Okay? Just copy everything in. Okay, so then the next chapter that I'm planning to go through is I'm thinking of going to lens first because I want to go through like the more difficult ones. Because usually I would say kinematics, dynamics, or your nodding agreement. Yeah, kinematics, dynamics, and lens. I think these 3 are the most difficult ones. So we do the more difficult chapter first. Okay, so lens is like on the one of the last few page. Yep, so can you all flip to this page now? Okay, so for lens. Okay, so for lens, definition wise, I think in the notes you do see like a list of definition. The most commonly tested one, I would say it will be focal length, which is small letter F. Yeah, then sometimes they will also ask you like, can you decide like from the drawing they show you, is it real or is it virtual? Yeah, so for the topic of, oops, sorry, got typo error. Sorry. Can you amend it? It should be reflection topic. Yeah, so in the topic of reflection, you know, like the mirror reflection, usually if it's real or virtual, we tend to use words like, oh, can be captured on the screen or cannot be captured on the screen. Because for example, like if this is like maybe the mirror, then if I put a screen behind, by right, I see my own mirror image, right? But my image cannot be formed on the screen. So that is called virtual cannot be captured on the screen. As compared to like maybe your school, you got the classroom projector, they shine it on the screen, and then yeah, you can capture it on that screen. So classroom projector are real images. Okay? So because can be captured on the screen. But then for the chapter of lens, lens we don't really like say screen because you know if you look at the textbook, that table, you know, the one, all the different scenario, yeah, it's like we don't really like place a screen there. Yeah, so how do you decide if it's real or virtual? You look at the light ray. Does it converge or not? By the way, what's converge? Converge comes from the letter C. That means it's like letter C. Does it meet at the point or not? So if it converge and meets at the point, that's called like also for converging lens. So converging lens usually is that the light ray will meet at the point. So converging lens need to know it is also this symbol. Yeah, is where the light ray will actually meet at the point. So for the light rays, I don't know, you all understand what I'm drawing? Okay, I label it clearer first. So for converging lens, usually picture they draw like that, right? But the actual symbol, the symbol is a double arrowhead like that. So usually when they have the light ray passing through, you realize the light ray will all meet at the point because C for converging, C for the light ray will actually meet at the point. Sorry, yes? Oh, okay. Then next is there's diverging lens. So for diverging lens, it would be like that. Yep. So for diverging lens, it's where because as the name suggests, diverge. That means it will, like example, you spread out your resources, you diverge out your resources. So that's why diverging lens, it will be that the light ray will actually spread out. So for diverging lens, they also have their symbol. Yeah, so the actual symbol, it will be this way instead. The arrow is pointing opposite direction. Okay, so then in this case, the light ray, what happened? The light ray will actually diverge. Oh. Diverge means spread out. So this is how the light rays will be. Yep, so as you can see, if it's real, usually they will meet at a point. Then you know in the textbook, you know the table, right? The always very often tested table. Usually they will meet. And then when they meet, that's where you draw your arrow, your image. Yeah, so that's why real means that they can meet at a point. Virtual means usually the light will just keep on bigger and bigger and bigger and bigger. Like it will never ever meet. That's why usually if it doesn't meet, you need to like dot it backwards to like force it to meet. So that is called virtual image because the light ray don't meet. So that's one way to tell. Another way to tell is you check your object and image, is it same side or opposite side? So if it's like one on the left, one on the right of the lens, this is real image. If both on the left side, then this is virtual image. So that's another way to decide. Okay, then in this topic also need to do calculation, right? The magnification calculation. So for magnification formula, how to remember, right? My way of teaching students how to remember is, you know, the first thing when you see people, or maybe like my first time seeing you, I will say hi, like oh welcome, take a seat, something like that. So the first thing you always say is like hi, correct? So that's why when you write, you always write hi first. Because that's the first thing you say, right? That's the first thing we do. So write hi first, then ho. You don't say ho when you see people, right? So you say hi first. Yeah, so hi, then ho. That means in other words, image height, then object height. Next, my student also very confused, like V and U. Which one is object? Which one is image? Like cannot remember. Okay, so how to remember? You go by kinematics that I teach you just now. Remember, just now kinematics, we also got V and U, right? Over here also got V and U. So how to use kinematics to help? In kinematics, you already know that V is final, right? I think by now you should remember that V is final, U is initial. So if you have a lens experiment, initially you will have object or image first. Initially, before you even start anything, even turn on the light. Originally, you have the object first, right? So that's why initially should be object. That means U is object. Okay, so that's the way to remember. That is mentioned here that U is object. That's why V is finally. Finally, after you do the experiment, yeah, finally I'll produce an image. So V will be the image. So that's the way to remember. Yep, so this is the formula. Then after you calculate, you also need to know what does the number mean. Like if the number is like 0.5, what does it mean? So if it's less than 1, means the image is diminished. That means now the size became 0.54, that means became half the size. Or if my number became like 5, 5 that means it become 5 times bigger. Because bigger than 1 means it is magnified by 5 times. Then next, to calculate the focal length, this one doesn't matter. Is it U first or V first doesn't matter lah. So this one is easier to remember for this formula. Yep, like that. Okay, then next is for the ray diagram. I don't want to copy and paste from your school notes or textbook again. It's the same thing lah. The table of course must study, but when you study, you don't study one by one. You study one by one, it's very hard to like answer questions. What you need to know is you look at them as a whole. So if you look at them in general, right, is that whenever you draw the light ray, it should be that the horizontal line should become a diagonal line and cut through F. So what do I mean by that? Okay, so let me just show it to you from my notes. This is my wait, let me just use my lesson notes to show you because there is the table. Hold on. Yep, over here, this one. Okay, so normally when we look at them, right, usually how we look at it is that the horizontal line should become a diagonal line and cut through the point F. Okay, yeah, so this is the usual rule that you draw. So horizontal must become diagonal cut through F, or if it's a diagonal line like you see here, diagonal that cut through F, it will become horizontal line. Yeah, so those of you who have the revision kit is on the last page of this revision kit. Yep, so then so that's one. Then next is all the diagram, you must make sure that they all have the line that cuts through the optical center and then it is not bent. So this is the compulsory light ray to draw. So you look at all the diagram, they will always have this compulsory light ray. Okay, so this is a must draw line. Then next thing to know is that as you go down the table, you realize that the object and image, they actually move in the same direction. So that means like, for example, right, okay, maybe let me make it bigger, a bit too small. Oh no, It's even smaller now. Okay, so if you were to look at them, right, as you go down the list, you realize that originally the object is like infinite away, distant away. Then now my object moved a bit nearer. So my object actually from far away, I actually move to the right. So what happened to the image? From F, at F, which is here, it moved to the right. Can you see that object and image, they move in the same direction? So that's the second bullet point that I was saying inside my notes, which is, let me change it. There, over here, can you see? I mentioned that object and image, they move in the same direction, but different amount, different amount. Because let me show it to you some more. So if we were to continue down the list, so in this case, if I were to have the object from beyond 2F, now I shift it nearer. Can you see? From beyond 2F, I shift to 2F. What happened to my image? My image is between F and 2F here. Now it also shift to the right. So the object and image, they actually shift together, okay, in the same direction but different amount. So maybe one move more, one move less. But I need to know that they move in the same direction. Because sometimes question teacher will say that if I were to move my object to the right, then where should you place your like screen on so that you can form a sharp image? So you must know that the screen also move in the same direction. Okay. Then next question is, you know, over here you keep seeing the word inverted, 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 right? All these words inverted, do you know what does it mean? How is it inverted? I think yours should be at least know one. Like that, right? Upside down. Correct? That's one. Then do you know that actually the inverted also include left, right, inverted? Yeah, so it's both left, right, and up, down, inverted. Okay? Then, yep, so what I've just mentioned to you is also shown in the notes here. That when it's inverted, it's both way inverted. And then when the lens is blocked, like bottom half is blocked, the image will become dimmer, but the whole shape, everything is still there because the top half of the lens can still allow light ray to pass through. And then when the object move closer, generally the image will become bigger and bigger and bigger for all scenario except the virtual one. Only magnifying glass. I think you know, right? Magnifying glass, you can't possibly put it like on your worksheet. If you put on the worksheet, it's not magnified. Usually you need to hold it at a distance away, then it will be magnified. Okay? So that's why for magnifying glass is that if you put the lens and object too close, not quite magnified. But if you put the for other scenario, yeah, usually is that you put it closer, then it will be bigger. Yeah, you can see it in the table also. Then next is when it is diverging lens, be it the object is at which position, somehow the image will be diminished lah. Yeah, like that. Okay, so let's take a look at a question. So maybe let's take a look at this open-ended here. So let's try to draw the image. Yep. So first is, okay, maybe for part A, let's identify first. Do you all think is it converging or diverging lens? Do you all think is it converging or diverging lens? Can tell? You feel that it's diverging, is it? Is it? Okay, so now how to tell? So originally, if you extend out the original light ray, it's like that, right? So now, which way is it moving? Is it moving further away or is it coming towards? You look at the light ray now, it's coming towards, right? So isn't it like letter C like that? The light rays are meeting. So this is actually a converging lens. Yeah, so you can circle the answer, converging. So mainly you just say that mainly is because it is actually bending towards that horizontal line. What's that horizontal line called? What's it called? Not normal, it's called the horizontal one. You know the lens? Then this line is coming towards that line, right? What is it called? What is it called? What is it called? Huh? You forgot what? It's called the principal axis, okay? Yeah, so that means mainly say that it bends towards the principal axis. Okay, then next is need to draw the light rays. So for the light rays is that you just draw it such that it's like you draw in the compulsory light ray first. Yep, so for the first step, you draw in the compulsory light ray, which is from the tip to the center, you extend it out. This is always the compulsory light ray, right? Yep. Then next, how do you continue to draw? Can you draw it first? I get those physically attendees outside to come in first. Hello, yeah, you can come in and take a seat. I'm almost finishing the physics. Yeah, you can take any available. You all know how to continue? Okay, so to continue, it will be that you draw the so the thing is that to know where your image is, you have to extend out this line. So when you extend out this line, and then you also extend out this line, the point where they meet, that will be your new image. Okay. Then likewise also for the other point also, always draw in the compulsory light ray. Then after you draw in the compulsory light ray already, you extend it out. Yeah, so once you extend it out, so this will be where your new image is. So the image, can you see the arrowhead is where they intersect? Then just draw a straight line until you reach the green line. This will be where your image is at. Yeah, so this will be the answer. Done. Okay, sorry, I need to switch over to the chemistry because there will be people in the waiting room in the chemistry link. It's a different Zooming. Yeah, so you'll just go over to OVERMUGGED Telegram O-level channel to access the chemistry link. So I'll see you again in the chemistry class if you are staying on. Okay, so I move over to the chemistry class already then. I shall end the meeting already. Any of you want to take a screenshot or anything? You want to take a photo now? I'm changing the screen already. Because once I end the meeting, this will be gone. Yep, so come and join me in the chemistry class, okay? Then bye-bye. See you again.